Good morning, guys. This is Sridhar, CSC department. Uh, the continuity of analysis design algorithms. Another most important pattern matching algorithm is Boyer-Moore. It's Boyer-Moore string matching algorithm. One of the most important as well as fastest algorithm when compared for among all these string matching algorithm. This string matching algorithm is developed by two scientists named as Boyer as well as Moore. Because of these two scientists' name, the algorithm was introduced. It was a particular efficient algorithm, so they served as a standard benchmark for the string searching algorithm ever since. The Boyer string matching algorithm. There are two texts will be there. One is a main text, another one is a pattern. So the pattern matching problems are very popular among the string problems. There are some well-known and most efficient user algorithms like KMP algorithm. So next class we talk about for this KMP algorithm, that is Knuth-Morris-Pratt algorithm, Robin-Karp algorithm, Boyer-Moore algorithm. This Boyer-Moore algorithm is very similar for the KMP algorithm. So, but whereas that application is quite different Boyer-Moore as well as the KMP algorithm. Before learning for this Boyer-Moore algorithm, first we should do some necessary pre-processing steps to executing this Boyer-Moore algorithm. This Boyer-Moore string algorithm in which a string length of n, that is what text we name it as the text length will be the n, and pattern of the length m is nothing but a searched one. So it prints all the occurrence of the patterns in the text. Boyer-Moore algorithm needs to pre-process the patterns but not the whole entire text. So what is pattern will be there, that pattern only will be matching in that text itself. The main key feature for that Boyer-Moore algorithm, so it will be matching from the tail end of that pattern rather than for that head from the pattern. We will see in an example so how it will be matched. So first what executing this algorithm, first we need to construct a table, name it as a bad match table. This is a very important bad match table. So first we construct the bad match table. It's a pre-processing steps. From that we developed the Boyer-Moore string matching algorithm. So how many number of elements the bad match table? The number of elements never has a smaller than one element will be existed in the bad match tables. Always we need to keep on comparing for that pattern as well as the text strings from the rightmost character in that pattern. So if the pattern is matched, then you go for the next rightmost character, like that from right to left all that pattern to string will be matched. Suppose if the mismatch occur, what will be happened? If it is a mismatch occurs, we have to shift that pattern to the right corresponding to the value in the bad match table. So an example I will show you how it will be shift that pattern. Make sure you have the table does not contain any repetitive characters. For example, if the text having j characters are there, several j characters are there, but in bad match table will contain only the one j letter will be there. So how will be calculated? How the values will be stored in the bad match table based upon this formula. So maximum of 1 comma the length of the given pattern minus what is that actual index of that particular character, what the character we are calculating, that actual index of that character, and minus 1. One more time, max of 1 comma length of the pattern minus actual the character index minus 1. We'll look at one example how we construct the bad match table construction. For example, a text is given like this. This is a text, a pattern is a text. I need to, using Boyer-Moore, I need to find out whether the text is presented in this main text string or not. So previously what I from that algorithm, first we need to construct the bad match pattern table we need to construct. So before that we need to separately individual how many number of characters are there in this one. How many number of characters are there? TEST test, the pattern, this is a pattern, right? TEST test. So we giving the indexes for everyone. The text will be T0, 1, 2, 3. So indexes of every pattern text will be given. Now this is what the bad match table constructed. So how many number of characters I have to take it? See, there are the 4 characters. Among the 4 characters, T, the character T is repeated twice, but whereas in the bad match table we take as only the one time, and E is one time, and S is one time. And the last, whatever the character is there, the last will take is the hashtag symbol. I will give that there is a significance for the hashtag symbol it is. Okay, using this formula we need to fill that all the character values. We'll look on one by one. So how we are calculating how the value will be the fill one. For example, I need to, what is the value of the T? So in the index, the formula, keep on remember the formula, we need to find max of 1 comma length of the pattern minus actual index of the minus 1. What is the T index value? T index value is a 0. So T index value is 0. Put all the values in the formula, max of 1 comma. What is the length of the pattern? Length of the pattern 1, 2, 3, 4. The length of the pattern is a 4 minus what is the actual index? Actual index of the 3 T is 0. So that is 0 minus 1. 4 minus 0 minus 1, that is 1. Max of 1 comma 3 among these 3 is right. So that you place the 3 value here over here. Similarly, we need to find out the next one. Can you guess what will be the next one? The E. Exactly what you are saying, that is a 2. So that is index equal to 1. So that same max of 1 comma. So the pattern length minus the index of E is a 1 minus 1. So 4 minus 1, that is max of 1 comma 2. Among these 2, which one is a max? 2 is a max. The answer is a 2. Similarly, can you guess what is the value of this S? S, exactly right. S equal to the 1. You are right. So S equal to. Now you have some little bit confused. Still there are one more T will be there. So T, E, S we are calculating. There is one more T. What is this one? What is the T value? Again we are calculating the index of this T. Where the index of the T is 3. Now you calculate max. Now the T value equal to the 1. You compare the previous, the T value is 3 and next the T value is 1. Now you have to update that value, T value. Here you can update the T value. So by default, which is having the minimum value, we have to consider that value. Now T equal to that 1. Exactly whatever that pattern characters are there, all the patterns characters values we got. Then what about this star? The star is nothing but what value we have to print in that star. So it will be the length of that pattern you have to represent over here. The 4, what is the length of the pattern? The length of the pattern is 4, so that we can keep the value as a 4. Exactly. Now we completed for the bad match table. We consider the bad match table. Then we look on for that example. Whether this pattern is, whether the pattern is existed in this given string or not, we need to exist. So we keep on this. We know, as we know that after constructing the bad match tree, now this is a text, our string. This is a pattern. Now what is the first step we have to do? So as earlier from the theory, I told you that the pattern character is matched in that text character from the tail end, not from that head, not from that head, from the tail end. You need to compare these two characters. So this is the beauty of this Boyer-Moore algorithm. You compare these two characters. If these two are not matched, what will be happen? If it is not matched, see here. So if it is not matched, now we look on to that. What is the character? S is existed in that bad match table is there. Yes, S is existed in the bad match table. What is its value? S equal to the 1. Now since S equal to 1, we can move that the pattern one position to the right. One positions to the right. Now so from always you start from the next position, this one position to the right. Now after placing this, so one position to right, we place that one position to right. Again you compare the string, the last character strings. Now compare here these two. What is a character? Here the space, I am comparing the 3. So these are mismatched, so that again, see, is there any spaces there in that bad match table? since there is no space, then what to do? How many number of characters I can move to the right to that pattern? In that cases, this asterisk will be help you. Suppose if the star is if the space is not available in the back match table, now take the star value. So the star is a 4, so that 4 positions you can move. So it starts from here. Now calculate 1, 2, 3, 4 positions. Now start from here. Yes, exactly 4 positions you can move. So you start 1, 2, 3. So always I told you the next position 1, 2, 3, 4. Now next the text will be moved on from this position. Okay. Yes, exactly. It moves for this position, right? Now you compare entire these. Now again mismatch is occurred. If it is a mismatch will be occurred, what I have to do? I have to check that A is mismatch. A is available. No, it is not present in the batch match table. If that character is not present in the batch match table, I told you that you have to take that star value. What is the star value? That is asterisk value. That asterisk value is 4. So that 4 steps you can 1, 2, 3, 4 steps you can move on this one. So take the steps 1, 2, 3, 4. I told you from the next position 1, 2, 3, 4, 4 steps. After moving this, it will be move on like this. Okay. Now compare these two. Exactly. Still these two are not matched. What will be happen? What is that S? So in the back match table, S is present in the back match table. Now how many position I can move to the right of that pattern in that text? So one position. So one position you can move. So not from the here, from the next position, from here. You can start from that here. So it can move next position. Okay. Now you compare that the rest of these two. Compare these two, the last. Compare if the two characters are matched. If it is matched, you can move to that from right to the left. Again compare these two characters. If it is matched, again it go for the next character, move to the next character. If it is true, move to the next character. If it is compare, so the two characters are the same. All the characters in that pattern should be matched in this string, so that the pattern is existed in this string. It is one of the fastest algorithm ever, an algorithm in a Bohr-Meier algorithm. Well, look, I hope that you can clearly understand that example. So what is an advantage for this one? Instead of comparing all the values, we are moving the pattern based upon that bad match table positions. This is executing very fast. This is a fast if the string size is increased. If the string size, that is a text size, is slow, so that you cannot observe the fastness of that algorithm. If the text size is very big, so Bohr-Meier algorithm, because we are skipping many number of characters based upon that bad match table values. We'll see. I hope that you can clearly understand what is example for the bad match table. Now some glimpse of this Bohr-Meier string matching algorithm. This what algorithm always takes a backward approach, as already you know. For that pattern here maybe is P and text is a T, so always we need to compare the characters patterns from right to the left. So from the beginning with the rightmost character, if a character is compared that is not within that pattern, no match can be found by analyzing any further aspects at this position, so that pattern can be changed entirely, past the mismatch will be occur. We'll see that example, how that example will be occur. So for that, how the pattern alphabets we need to calculate. That's bad match table we need to calculate. So before that we need to compute the length of the pattern M, we need to calculate. For again you need to calculate for each alphabet. For each alphabet we need to calculate in that sigma. All values will be stored in that L, that stored the last occurrence of that value for each alphabet. From that we need to compare for that each and every character. Next also we need to find out the good suffix. Good suffix is nothing but here. So these are the good suffix, right? This whatever that green mark I have to represent, these are all good suffix. How it will be good suffix? This is also will calculate using computer prefix. This good suffix, and also finally Boyer-Moore algorithm, how it will be executing Boyer-Moore algorithm, the length of the P, the length of the pattern as well as the length of the text, and you need to find out for the pattern what is the last occurrence character, whether it is a good suffix, that is if this matched or not, we need to check for this one, and repeat that process using a while loop. You repeat that process until entire pattern will be matched in that string. So this is about an algorithm. Now what is the complexity of where m is what the length of that pattern, where n is the length of that string, so that the time complexity will be order of mn. So in worst case it will be the order of n log m by divided by m, of course. Where applicable that it will be applications. This algorithm is highly useful in tasks like recursively set files for virus patterns, searching databases for keys or data, text and word processing, any other tasks that require handling large amount of data at a very high speed. Thank you guys. I hope that it is very clear to understand that Boyer-Moore match algorithm. And next class we will see on for that KMP algorithm. Thank you once again. Have a nice day.